Jeff. There you go. When I say the word polynomial, does anything come to mind for anybody? What comes to mind? Yeah.
Like multiple different like variables.
Kick ass. There was a word I thought you were gonna say, and you're like, oh well. But what kind of stuff can you put together? Like terms. So multiple terms separated by plus or minus. So we're gonna build the parts of a polynomial first, and then we'll talk about polynomials. There is a type of function called a power function. Do I have this around this? Any ideas as to what the hell that function might look like? A power function.
Something to the power.
Holy shit! Because math people were very creative.
There's a function with a power. We're gonna call it a power function.
So it's a power function is literally just this. It's just x to a power. I'm trying to remember. I don't think this book puts coefficients, but I can't remember if that's true or not. Doesn't matter too much. So some of you guys might realize this is sort of like the building blocks of a polynomial. Could somebody give me an example of a polynomial? Anybody? Does anyone remember? So you've all heard polynomials, heard that before, but you might be sitting there like, I've heard it before, but I don't know why or what. Do you guys remember the word monomial, binomial, trinomial? I love one reaction to that was no. Okay. Triceratops? No? Okay. So, polynomial, here's a polynomial for you. X squared plus 5x plus 7. That's a polynomial. It's like Kevin said. It's a series of terms, multiple terms. All of it. Poly is multiple. Nomial is kind of like related to terms. They're actually names, but we call them terms. This is broader than that. This says this could be any number. So for example, is this a power function? Yes. Is x being raised to a number? Yes. Okay, this is a power function. Is this a power function? How can I rewrite a square root? What power does it become? So is this a power function?
Yeah.
Yes. So it's not just if it already is written as a power, but if it can be written as x to a power. Sort of like we all know 0.33333 forever. What fraction is that? 1/3. So if I say 0.333 forever, that is the fraction 1/3. It's not written as a fraction, but it is a fraction because it could be written as a fraction. Kick ass. What about what, Jeff? What about this? Is that a power function? Yeah, it's x to a number. So what about this? Now, quick side note. What is 1 over x? How could I rewrite 1 over x? We'll come back to him. He's free. X to the what power? -1. So is that a power function? Yes. Why? Because it's x to a number. What would this be? Is that x to a power? Is that x to a power? No, it isn't. What is it? It's x plus 2 to a power. So is this a power function? No. Sorry. Do you guys see that? It's that simple. If I can rewrite it as x to a power, it's a power function. X plus 2 to a power is x plus 2 to a power. It's not x to a power, so it's not a power function. Okay. Yes?
Why is 1 over x to the
Do we know, did I talk about that? The negative power? Do you guys know why a negative power? Oh, okay. Quick side note, since I did that. Remind me how would you simplify this?
X to the third over
Good, because how many x's would cancel?
2.
You guys, can you see them in your head? There's 5 x's in a row divided by 2 x's. So you would slice through 2, so how many would be left? So what's the shortcut? 5 minus 2 is 3, yes?
Yeah.
That's a 3, believe it or not. So what if I had x to the 5th over x to the 6th? How many x's cancel? And how many are left? 1, where? Oops. On the bottom, so that's 1 over x. But what is it also? What did you just tell me I do?
Take away.
So what's 5 minus 6? Negative 1, so there you go. X to the negative 1 is 1 over x. How do I lose an x? I divide by an x. That's why x to the negative 1, which is losing an x, is 1 over x. How would I make, what would I do to x to the 7th to make it become x to the 6th? What would I do to it? What would I do to it? To make it become x to the 6th?
Multiply the x to the negative.
Yeah, okay, good. I would do this, because what do I do with the powers?
U.
What do I do with the powers here? No. Alright, what would this be? Did we not talk about powers? Let me see.
Nothing.
Maybe this is a good time. Exponent rules? What's this?
5.
Now, real quick, alright, I thought for sure I had, but maybe we just haven't. Let me blow your guys' mind. You ready? You ready? What I just wrote, there is no 2. There is no 3. And there is no 5 in the answer. There isn't. There's no 2. There's no 3. And this is where you guys get up and go, this guy's off his meds. I gotta go see the administration. What the shit does that mean?
X times X.
There's 2 x's multiplying. What does that mean? 3 x's. X's. All that's up here is x's, yes? There's no 2, there's no 3. There's x times x times x times x times x. So of course then how many frickin' x's are in a row then if there's 2 here and 3 there? Freaking 5. That's why you add when you multiply like bases. You're just accumulating how many x's are in a row. Does that make sense?
Sort of multiplication.
Okay. So when you, this is kind of dumb, but I'll show you. A long time ago, I was dating somebody who was like, not dating, that's terrible. I was helping somebody who was cheerleading, and they said, multiplying is adding powers. Multiplying like bases, you add the powers. You guys see that? Okay, whatever helps. So that's why when we divide, we subtract, because it's the opposite operation from multiplying, which is when we add. So going back up here, do I have like bases? Yes. So then what do I do with the powers? Add them. 7 plus negative 1 is 6. But what is x to the 7th times 1 over x? What happens here? What happens? What happens here?
That is also X to
Why? I lose an x, don't I? One of the x's cancels, yes? So what did this act like? This acted like this. So that's another kind of way to see why x to the negative 1 equals 1 over x. So let me just summarize what we just did. A negative power flips. That's all it does. A negative power flips. So if I had, what is 2/3 to the negative 1? Don't overthink it. 3 over 2. What is 1 over W? 1 over M to the negative 11. Don't overthink it. Don't overthink it. What's the negative power do? Flip it. Where are my 11 M's currently? On the bottom. So they're going to flip. So what's it going to be? Why is it not negative anymore? Because if it was still negative, it would just go up and down forever. So here's a dumb way to look at this. You ready? m to the negative 11, it don't like it down there, that's why it's negative. So when you put it up top, it's all happy, it's all positive, man. Oh, you guys got okay? Or no, it doesn't matter, you don't have to do that ever. You never have to think about that ever again. So negative power just means flip. Okay. Okay. So there's really not much to power functions. I do want to say this. What does this graph look like? If I graph this, can you guys do it in the air for me? What would that look like? Yeah, we better know this. We've been moving these things around and everything, right? So this is to be a parabola. Wee-haw. What would this look like? You guys know. What's 1 cubed? 1. What's negative 1 cubed? What do you get when you cube negative 1? Negative 1 times negative 1 times negative 1. Negative 1. And what's 0 cubed? So if you're not careful, you make a straight line. But it's like a parabola on this side, and this side is the parabola that fell out. Yes? So I call this cubish. One of my colleagues calls it a giraffe graph. And I always joked him, I said, somebody cut the poor dude's front legs off? Because he's saying, imagine there's front legs going. All right, very sorry about that. Yeah, I'm talking about zombies eating people, freaking giraffes with the legs cut off. I'm sorry. Say again?
Next is giraffes.
Giraffes, zombies, giraffes, exactly. That's the next thing. Their big ass necks, they get around the corner. Oh, jeez. I don't want to think about it. Somebody's going to make that movie.
Where is it?
What do you think? There's a movie called Black Sheep about sheep zombies.
There's some like crazy zoom.
Brain Dead?
I don't know.
All right, Peter Jackson's first movie. That's insane. What do you think x to the 4th looks like? Let me say this. Why does x squared look like this? What can a square output not be if we're only using real numbers? Can only be positive. So it's like, yay! Oh shit! I can't go negative. I better turn. Okay. And this guy is cubing. The answer could be negative. So that's why he's like, oh, that's no problem. Okay. So what do you think x to the 4th looks like? Same thing. Y'all with me? What does x to the 5th look like? X to the 6th, x to the 7th, x to the 8th. Am I going the right way for you guys?
Yeah.
I think so. Yes, I am. Good. You guys, so what's the x to an even power looks like this? And x to the odd power looks like this. Okay. Now, that's basically all section 5.2 talks about. The thing I want to focus on for the last part of class is this. We are going to get to the point where if I'm given a polynomial that looks like this, I think that one actually works. I can't remember. We're going to be given a polynomial like this. We're going to factor it. Now look at that. Look at that polynomial. Can we currently factor this polynomial? How many terms does this thing have? 5! I could try grouping, but that would be weird as shit. So we are currently incapable of factoring this thing, which is not our fault. I just haven't shown you how to do it. We're going to learn a process that makes it really easy, or makes it easier to factor these things that we could not factor any other way. Once we factor this thing, so I'm not saying this is the answer, but let me put a different function. If I have it factored, can somebody even, so let's say I factor something, I get this. Can you guys tell me what the x-intercept is? X-intercepts? What does an x-intercept do? If I plug the x value of an x-intercept in, what should I get out?
0.
I should get 0 out, right? So what are the x-intercepts? Here. -3, -3, 0, and
4, 0. So negative 3, 0, and 4, 0. Those are the x-intercepts. So when it's factored, it's easy to find these. Yes? But now our question is, how do I know what this thing looks like? Look how it's got an even and an odd power for 1. You guys see that? So like if I multiply this out, what's it going to end up looking like? And it's easier than I'm making it sound. I'm not really trying to make it sound anyway, but first thing I want to do with you in this direction, you're going to need calculators, and everybody said they had a calculator.
Like this is the function of the number 2, but you would use the second all the different numbers, like for let's
Yeah, we already forgot the table.
it's taking this as the like this is the output.
Yeah, that's what I was doing, but it's a little slower.
Let me show you something that this little table here has been talking about. We're going to kind of check our answers this way too. So if you have your graphing calculator with you, I'm going to do it maybe a little different way than you guys did. Do you see how I put all the parts up in there? I put the x minus 1 by itself, the x plus 2 squared by itself, and then the function there by itself, yes? So my intention for this paper was you'd fill in the first table, fill in the second table, and then multiply the entries to get the last table. Because that's how you make the function, is you multiply x minus 1 times x plus 2 squared. But here's a really nice thing that this crazy expensive thing does. Do you see above graph where it says table? That's very hope inspiring here, right? Do you see over here where it says table set? So, if you have your graphing calculator with you, go ahead and hit second window to go to table set, and you get all this business. Okay. Does anyone know what that symbol means? Besides, like, it looks like a home plate, home base. Delta, I love it. It's a Greek letter, delta, capital delta, lowercase delta means a little d that had an behind. Delta means change in. So sometimes your professors might have told you slope is delta y over delta x. Change in y over change in x. Okay. How much does the table I gave you, how much do the inputs change? 0.5. So I'm going to make this 0.5. Obviously, I'm going to make the start what? Where does all my tables start? -3. So make the table start at -3. Be careful, use the right negative. This one, that's a minus. If I use minus, I'll get this error. Basically, this means, what the shit? So if I hit go to, not Goku, hit go to, it'll put the cursor on the problem, and I'm like, oh shit, I used the wrong negative. Make this 0.5, or you can even just put in there 1/2, and it'll just replace it. You guys kind of with me? Sort of, maybe? If I hit now second graph to go to table, it will now, why are you starting at -6? Did I not change that?
No, you left that.
Dadgummit, Jeff. Let me go again, hit the table, and now it's showing me, this is all the numbers that should be in your first table. There's all the numbers that should be in your second table. And this is all the numbers that should be in your last table. Is that, you guys with me? Is anybody with me? Okay. Is that true? Is that like, if you look at the numbers in your first table, did you get these numbers? Okay, let me just take a minute. Are you guys in this room with me right now? Okay, I'm really concerned about myself. I'm like, I'm 90% certain I took my meds this morning. But I'm like, I could be in the corner hallucinating this whole thing. That's why nobody's responding. Did you guys all get those blue numbers in the first table? Okay, if you didn't, let us know. How about the red? Oh, you got it? Thank you. Oh my God, thank you. The red number should be the second table. Time to wake up. And then if I multiply these two, I get what's over here, yes? Of course I do, because the function is x minus 1, what is x minus 1? Times x plus 2 squared. Is that what it was? I think so. Now here's what's really important. Did the rest of what I asked you on this paper make sense? In that first table, does it ever change signs from negative to positive? On one side it's negative, on the other side it's positive. Does it ever do that? Like, what is it at 1? 0. Why did I lose 2? Oh, I went up with one step. Dadgummit. At 1 at 0. What is it below an input of 1? What's the output? They're all negative. What is it above an input of 1? What are the outputs? Positive. Okay, let's just keep that in mind. What about table 2? Did the sign ever change? No. Where is it 0? At -2. And that makes sense, because x plus 2 squared, -2 makes it 0, yes? But below it it's positive, and above it it's positive. And why is that not surprising? Because it's squared. So of course, I need you to see around 0, this is going to look like a parabola. Because it came from a term that had a second power on it. What if it had a fourth power on it? It'd be the same thing. It would be different numbers, but they would all be positive, yes? So what was the power on the one that controls this table? What was that expression? First table? This was x plus 2 squared. This was?
X minus 1.
And what is that understood to be to a power of what? 1, which is an odd power, which means it would go through, which means it changes sign on either side. And we see that. We see it over here, it's below the x-axis, and then it goes through the x-axis. Over here, it's above the x-axis, it hits 0, and then it turns and it's above the x-axis still. That's what a parabola does. So on one level, you're all sitting there like, yeah, we know this shit, what are you talking about? But when you start combining them, we start to feel like it doesn't still do that same thing. It does, which is really cool. Look at the end result. Is there a 0 around which the sign did not change? Where are my zeros in the last? It's here and here. Did the sign not change around one of those zeros? What is the sign below 0? It's negative. What about above 0? Negative, yes? So around this 0, around -2, it stayed the same sign. And where did -2 come from? X plus 2 squared. So around -2, it's going to look like a parabola. it's going to touch its x-intercept and then turn back. What did it do around this 0? This 0 came from x minus 1, the first power, yes? What does the function do around it? Changes signs. So on one side it's below the x-axis, the other side is above the x-axis. Okay, maybe. So, I don't know if you guys got this far. So here, holy crap. Did the outputs change sign around something? Yes, around x equal 1, y equals 0. Around there it changed signs. Why? Because it was to a first power. Did the change signs? No. Why? Second power. And we're only dealing with real numbers, thank God. So when I square a real number, it comes out positive or 0. Here's the word. This word you're going to hear from me a lot over the next week or so. When I say multiplicity, so if I said, what was the multiplicity of the 0, -2? Where did it come from? Where did -2 come from? Where did -2 as a 0, where did it come from? Which piece of this gave me -2? Yeah. And what was the power on it? 2. So how often did -2 show up as an answer? Twice. So all the multiplicity is just the power that was on the term where that 0 came from. So if I said, what's the multiplicity of -2? You would say 2. What's the multiplicity of 1? 1. Because it came from something that was only to a first power. If it's got a multiplicity of 2, what's it going to do there? It's going to turn. If it's got a multiplicity of 1, what's it going to do there? It's going to go through. So look, let's graph this thing. I'm going to turn off these other dudes so they don't freak us out. And if I graph this, zoom 6. So what did it do in -2? This is the function, yes? This is x minus 1 times x plus 2 squared. What did it do? Did it go through the x-axis or did it bounce? Bounced off. Then it turned, and what did it do now at 1? It went through. Because that was a second, that was an even multiplicity, so it's going to act like a parabola around it. That was a first power as a 1, so it's going to act like a line through it. Okay, maybe. What is this function doing at the ends? Remind me, what's a cubic look like? Can you guys, here's a square. What's the next cube look like? Thank you, man. I always appreciate it. I'd like to see a sea of people doing this and just, I don't know what it is. But yes, it does like this? Okay. Isn't that doing this at the ends? This side is going up, yes? And this side is going down. Why is that true? Because if you were to multiply this out, can anyone see where the cube is? Why did it look cubic? This looks cubic at the ends. This is definitely not parabolic, you agree? This is cubic. Why does it look cubic? Where's the cube? Well, if I did, please, dear God, don't. But if I did multiply this out, can you guys see what the highest power would be? What would the highest power be? Yes. What would you get just from this dude? What would the highest power be if you multiply this guy out?
2.
Squared, and then I multiply by this, I get cubed. Yes? You guys all with me? So this function's highest power is x cubed. I'm going to go against what I just said. Normally don't do this, but I'm going to multiply this out. X plus 2 squared is this. I'll do it a little bit quickly. And then if I multiply this out, I'll do this a little quickly. X cubed, 4x squared, minus x squared is 3x squared. Minus 4x plus 4x is gone, minus 4. Neat. I like it. When x is really big, does this matter? Compared, If x is 1 billion, is this pretty big? Compared to 3 billion, does this matter? No. If I lose $4 as I am now, do I care about it? Yes. If I had $3 billion and I lost $4, I might not stop to pick it up. You guys understand? So 3 billion versus 4. This don't mean shit. Now, you all agree 3 billion is big, yes? If I made x 1 billion, this is 3 billion, yes? What the shit is this if I make x 1 billion? I'm not even sure off the top of my head I can remember the name for that. But it's 1 billion times 1 billion times 1 billion. That's a holy shit alien. You guys kind of with me? So compared to holy shit alien there, does this matter? No. 3 billion is big, but 1 billion cubed? This ain't nothing. So when x gets really big, which part of this dominates? Obviously, this guy. So the shape of the graph is going to be determined by him. When x gets small, which pieces dominate? These two. So on the outside, it's got to look like a cube. In the middle, it could wobble because of the little guys. They suddenly mean something when x gets really small. Okay, maybe. If x is 1, now 4 is huge. Are you kidding? 4 times as big. Are you kidding me? So when x is 1, this means everything. That's what makes the wobble in the middle, but at the ends, it's got to look like a cubic. So this is, again, did you guys remember, math people, very creative. We said, let's call that end behavior. That's how the function exists, how it behaves at the ends. So if I had something like, if I had something like this. What's the highest power in there?
6.
So what's the end behavior gonna be like? It's gonna be like that. So at the ends, it's gonna be like this. In the middle, it could wobble because it's got other shit going on. When x gets small, these terms get to play a little bit. So that's why in the middle, it could wobble. But at the ends, when x gets really big, positive or negative, this don't mean shit. It becomes effectively this. That's what end behavior is. I would much rather be given, let me see, this is a skill that we have to work on by itself. I would much rather be given something factored. Do you guys agree? Do you want to factor this? Do you even know how to try to factor this? It's okay if you don't, because I haven't shown you yet. Even if we knew how to try, it might not work. Wouldn't I rather have a problem just tell me what the hell is factored? Yes? So what if I had this? Can anyone tell me what the highest power would be if I multiplied it out? That little tilde means like approximately. In this case, it means goes like. If I did multiply that, what would the highest power be? Can anyone see it? What would this guy give you? Just him by himself. If you multiply him, don't do it, but if you did, what would the highest power be? Everybody with me? Squared, yes? X squared plus blah, 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 blah. What about just this guy? Third. What about just this guy? So you got x squared plus shit times x cubed plus shit times x to the fourth plus shit. What's the highest power? X to the? No, come on. Are these multiplied?
Yeah.
So if I take the x squared term from here times the x cubed term from here, let me do this. Do you all agree if I multiply this out, it'd be x squared plus blah, blah, blah? Do you all agree this would be x cubed plus blah, blah, blah? And do you all agree this would be x to the fourth plus blah, blah, blah? If I multiply that stuff out, yes? So what is this times this times this? That would be the biggest. So what's the shortcut to figure out the highest degree? Just add the powers you see, yes? This would give me a squared times, this would give me a third power times, this would give me a fourth power. 4 plus 3 plus 2 is 9. Be really careful. If there's no power, it's a first power. Don't forget to add the 1. Yes? The reason we're doing this is, if I know what it's doing at the ends, we can then investigate how to know what it's doing the wobble, and then I got the whole picture. So the end behavior on this goes like x to the 9th. What would that look like? Don't think about the 9. Think about the fact that it's odd. So it looks like that. Yeah. At the ends, it's got to look like this. In the middle, it could be doing wham, wham, wham. In fact, here's a cool little thing to know. If the highest power, whatever the highest power is, what's x squared look like again? And I don't care how much I add to it, x squared plus 10x plus 7, it's going to look like this, yes? Maybe I turn it into, how many turning points does it have? Always. 1. So here's a neat fact. Whatever the highest power is, it can have at most 1 less number of turning points. So what's the most turning points this guy could have? 8. He could turn 8 times. Look back at our cube we did. So if I have a cube, what's 1 less than that? It's square. How many turning points did I have? How many times did it turn? Once, twice. So if I have a third power, it could turn at most twice. If I have a fourth power, 3 times. If I have a ninth power, 8 times. Stay with me. Okay, maybe. So end behavior, so this would look like this at the ends. That's what it would look like at the ends. In the middle, it could wobble. And that would be the next step of the problem, is to start thinking about what's going on in the middle. But the first step of the problem, either is factor it, or if it's already factored, you can talk about end behavior. Right? And it's nice, one nice thing if it's not factored is you can see the end behavior easy. The x to the 9th would be in your face, not kind of hidden the way it is now. Okay. Where was I? I took a tangent. Oh yeah. So, just keeping that in mind. For number 2, did every group get to number 2? Even if you didn't, can you tell me what the zeros of this function are? By the way, zeros are the values that you would input to make it 0. So it's just the numbers. What are the numbers that make this 0?
-3.
-3 and 1. That, of course, is the power of having something factored. What are the x-intercepts then? Good. -3, 0, and 1, 0. What are the multiplicities of each root? Does anyone remember what that means? Yeah, where did this guy come from? Came from here. And how often does that one show up? Twice. Do you guys see what I mean by when I say that? How would I rewrite x plus 3 squared? X plus 3 times x plus 3. So it shows up twice. So that has a multiplicity of 2. And this one has a multiplicity of 1. So what's it going to do here? When will it go through? Which one of these is it going to go through? And which one is it going to bounce at? All you got to do is remember what kind of function terms like that. What kind of function does this? X to the what power? X to the even power. And you're right, you're good. And what kind of power goes through? X to an odd power, yes? So which one of those will the function's graph go through? Which intercept? 1, 0, I like it. In the back saying, look at me. Okay. So this is going to go through. And of course, which one is going to turn or bounce? All right, so let's do this. We'll do this one thing and then I'll let you out early because I'll put you through the ringer a bit today. By the way, today is more of a I'm trying to lay a groundwork of an idea. Next week we'll get into the specifics of these, but I do want to complete this one problem. Let's graph this damn problem. Yes? Let's do something, Joe. All right. So let me remind us what we figured out. And let me allow myself to see what I'm doing. Where have I put my bubble? There. So we got this function. We know that the intercepts are -3, 0, and 1, 0, and we know it's going to turn here or bounce, and here it's going to go through. We also know the end behavior. What will the end behavior be? What would the highest power be? If I multiply this out, what would the highest power be? 3. So what would the end behavior look like? Like this, yes? So you just have to say like that. X cubed would be, I could just draw it. But this has a lot of extra terms, so I don't know what it's doing in the middle. All right, so let's see what we can do. Ready? I'm going to graph what I know. It goes through -3, 0. And it goes through 1, 0. Yay, Jeff. Can anyone tell me what the y-intercept would be? How do you figure out the y-intercept of anything? You can do it. You make x 0. What do you get when you make x 0? Make x 0, what do you get? 3 squared? 3 squared? 9 times -1. So what's 9 times -1? -9. So I know the y-intercept, when x is 0, I get -9. Okay, I love it. So this first go around, we're going to get a little more detailed later, but I'm not going to worry about it right now. I'm going to make a scale of 2 on my y-axis. 2, 4, 6, 8, 10. I can now graph this. So let me just stop there for a minute. I've graphed my x-intercepts and my y-intercepts. Those are my anchors for my graph. Okay, I love it. Look at my end. Now I'm going to graph this by hand. You've got to be really careful about graphing this in your graphing calculator. Don't just copy from the damn thing, because I can tell it's bad. It's not a good idea. Can anyone see how my end behavior helps me get started? Where am I supposed to start? Am I supposed to start up here, down here? Where am I supposed to start? You can do it. What's my end behavior tell me? Look at my end behavior. Where am I supposed to start? Up, down, down, down. Holiday Inn? No, okay. So I'm going to start down, right? So I'm going to start down here. So I'm going to start down here. I'm going to come up. I'm going to approach my x-intercept. What am I going to do when I get there? I'm going to bounce. Okay, so I'm going to hit it and I'm going to bounce. Which is good because I got to get down here, don't I? So I'm going to bounce and then I'm going to come over to my y-intercept. And then I'm going to get back up to here. What am I going to do when I hit this guy? Go through. Holy shit. Sorry, I'll calm down. Is everybody semi with me? Semi? That's cool. I mean, I know you have calculators. I know you paid a lot of money for them. I apparently don't give a shit. The thing I need to do for you, when you get to calculus, you need to be able to construct a graph, relatively good, quick sketch. The more you go through the details of it, the better your rough sketch is going to be, the better your calculus work is going to be. You have to know the shapes of graphs and how to get them very quickly. Can anyone tell me, there's one thing I could have done to improve my graph a little bit, besides, be a completely different person that's able to make a good scale? There's one aspect that I just kind of guessed at.
how do I know that this doesn't go deeper down here? Like maybe it went down and then up. In fact, it would have made this turn easier if it would have gone down further. How do I find out? Maybe about how far it goes down. How would I find that out? Yes, sir.
Try to find the point in the middle.
Yeah. So I could plug in either one of these. You guys tell me, which one should I plug in? -2, -1.
-2.
So, I think I heard -1 first, even though I heard -2 better. So here's the function. I'm gonna write it down again. Does everybody understand why we're doing this? I'm gonna start to do this every time now. I'm gonna find numbers between two things I know, so I know how deep or how high it's going. So if I plug in, I already just forgot what I was gonna do. -1? I can't remember. We'll do -1. What's -1 plus 3?
2.
Squared? Times -2?
Negative.
-8. So -1 was supposed to go here, yes? So then it seems like I would have gone down and then back up. Or maybe actually I'm close to right. Maybe maybe I just need to go a little bit down further. Okay. So it looks like we got actually close to it, just by accident. So that's one last step to this would be finding numbers between, we had that intercept and we have this intercept. So then I want to put something in the middle so I can see how high up or down it goes. That's the last step to these kind of problems. Okay, I think today that's plenty for today. That is so plenty. Go have a good weekend. Get started on test corrections. See y'all next week.
Could I take a picture of this piece of paper that we wrote everything?
Yeah. These two things?
Which one?